Hello and welcome again as we look at yet another multiple choice question for IB Chemistry. This one for topic 18. A buffer is produced by mixing 20 cm cube of 0.10 moles per dm cube ethanoic acid with 0.10 moles per dm cube sodium hydroxide. What is the volume required and the pH of the buffer? Now, buffers can be made by mixing weak acids with the salt of their conjugate base, or by mixing weak acids with strong bases so that you can make a certain amount of that salt. But to make a buffer successfully, you can't neutralize all of the acid. You need to leave some of the acid, like this ethanoic acid, in the acid state, and then you need to create an equilibrium between that acid and its conjugate base. Now, to achieve that, you need to convert some of these ions over to this side, so you would have a mix of both. If you were to neutralize all of these ions with the strong base, then you would end up with all of this. So therefore you won't end up with an equilibrium which would allow for the weak acid to behave as a proton donor and for its conjugate base to behave as a proton acceptor. And when small changes in pH happen, then the buffer is able to donate protons or accept protons, and that's how it works to resist changes in pH. So what you don't want to have with a buffer is all of this being exhausted. So you don't want to have, if you're using 20 cm cube of 0.10 moles per dm cube, you don't want to have all of that consumed. If you're supposed to use 0.10 here, to prevent all of the acid from being consumed and to leave some of it in this state, you would definitely need to use less than 20 cm cube. So therefore, immediately you have eliminated A and B as possible choices, and you're down to C and D. Now, the other question that could confuse students is, how am I going to calculate these pH values of the buffer? While there are ways to calculate the pH of a buffer, it does require data that's not provided in this question, and it does require the use of an equation that's not a part of the core syllabus. So students are not expected to calculate the actual pH, but you're expected to make a prediction about the relative pH, which means you should be able to say whether this pH would be above 7 or below 7. And because you're using 20 cm cube of ethanoic acid, and only half of that is neutralized by sodium hydroxide, it means you still have very much an acidic solution, because you're not going to add any extra sodium hydroxide. You're just adding 10 cm cube of 0.10 moles per dm cube here. And that's going to create a certain amount of salt over on this side, sodium ethanoate and water. And you'd still end up with a certain amount of ethanoic acid here. So you still have quite a substantial amount of this. And the point is, you should expect that the pH would have to be on the acid side. Exactly where it would be is not of any consequence, because you're now down to two answers and you would choose the answer of D.